Quadratic formula. This is a good one. You'll like this. Here's our quadratic formula. B, A, C. That's it. Every time. All we have to do is find A, B, C, and we plug it in. This is our formula we will use. The big key is where do we get A, B, and C. That's all we have to worry about. Once you get it, you put it in, plug it in, plug it in, plug and chug basically for the rest of the problem. So we're going to start at example 3 because of time. I want to make this all in one video since we're basically trying to get to this point every single time. Example 3, what they do is they don't set it equal to 0. All we have to do is start by setting equal to 0. Now, keep in mind that once you understand what's going on, you don't actually have to do this. We are looking for A, B, C. Our A is always the number attached to x squared. Our B is always the number attached to our x. And then our C is always left over. So there's A, there's B, there's C. So once you understand this, you'll know if it's not set equal to 0, you just look at what number you're going to have and make it your C. So our A is 1, our B is -6, and our C is 7. Once we get that, all we do is plug in. We'll do this one all the way through, and then the next one we might skip. I don't know. We'll see how much time we have. We have a negative B. So we have a negative B. Our B is -6. Plus or minus the square root of b squared. You can write -6, but it doesn't matter. You're always squaring your b here, so it doesn't matter if it's positive or negative. You're going to square it every time. Then we have a -4. That remains the same. That's a constant. So we always have -4 times whatever else is given. Our A is 1. Our C is 7. That's our numerator. Our denominator is 2 times A, which in this case is 1. So I have a -6, so that's 6 plus or minus. The square root of 6 squared is 36. And then I have a -4 times 1 times 7, so I have a -28. So I have 6 plus or minus 36 minus 28 all over 2. That equals 6 plus or minus the square root of, and I'll only have to take 36 minus 28, which gives me the square root of 8 over 2 equals 6 plus or minus. Now, well, one extra step real quick, because I know there were still a lot of questions surrounding this in section 6.2, I believe it was. When you have a square root of a number that's not a perfect square, you try to draw a perfect square out when you factor it. If it's a cube, whatever the index is, you're trying to pull one of those out. So I can pull out a 4. When I do, I get 6 plus or minus. My square root of 4 is 2. Leaves me with square root of 2 over 2. I can factor a 2 out of that top piece. And cancel those out. I'm left with 3 plus or minus the square root of 2. So there's your answer. We have 3 plus the square root of 2, 3 minus the square root of 2. Whenever that works out, if it was square root of 4 and just a 2, you'd add a 2 and subtract a 2 and get your 2 actual answers. In this case, we leave it because it has a radical involved, so we can leave it plus or minus. You don't have to write each one separate. Okay, let's do example 4. We'll do 4, 5, and 6 is my plan. Example 4 gives us 1/10 x squared minus 1/5 x equals -1/2. I'm just going to move first, then I'm going to get rid of my denominators. Remember, we want to set equal to 0. So I add 1/2 to each side. Now what I'm going to do is just I'm just going to get rid of my denominator. So my LCD. I multiply through by the LCD. You can do this every time to get rid of your denominator and have easier numbers to deal with. So I'll write my 1, just to help you follow along, minus 2x plus 5 equals 0. Now it's easier to see my A, B, C. My A is once again 1. My B in this case is a negative 2. It's this whole piece. There's A, there's B, and then my C is positive 5. Okay? So then I'll go over here for it. My x equals negative b. Well, my b is negative 2. So a negative negative 2 plus or minus b squared. So 2 squared is 4 minus 4 ac. 4 times 1 is 4 times 5 is 20. So minus 20. All over 2a. In this case, a is 1. So all over 2. So x equals 2 plus or minus the square root of negative 16 all over 2. We already know that after going through chapter 6, we know now we can have a negative underneath the radical sign. We're just pulling out an I. In this case, when we can pull out an I, but the square root of 16 is a perfect square. So we are going to have 4i over 2. Square root of 16 is 4, so I can pull out a 4. A negative means I'm always pulling out an I. So x equals, and I can factor out a 2, and when I factor out a 2, they go away. My x, my answer is 1 plus 2i, 1 minus 2i. So that's example 4. Keep in mind, here's the key concept that's new basically in 7.2 is trying to figure out what my A, B, C are. When I figure out my A, my B, and my C, then I just go to this formula, plug it in, and I'm back to using rules that I've already learned. I'm back to a process that I've already done. So this part isn't really new. The formula is new, but what we're doing we've already done. So don't get too worked up. The key is figure out where my A, or where your A, B, and C are. And sometimes it takes moving around. In this case, it took eliminating the denominator so that you could get rid of fractions. And the next example includes, I believe, let's see, our next example includes, it's factored out. Example 5 is already factored out. We need to distribute, to combine. So here's what they give us. So what we have to do is, it's already factored out nice and clean, but we have to combine everything and move that 4. We need an x squared to find out what our A is. We need a total x to figure out our B. And then we need what's left over with the negative 4 for our C. So we distribute, we get 4x squared minus 2x minus 6x. Minus 8, I don't have to put too much time in this, we've already been there, done that. Plus 3 equals negative 4. So in this case, to figure out my C, this is always C. Here's my A, here's my B, here's my C. So it's going to be 7. So my A is 4, my B is negative 8, and my C is 7. So again, I move over to my formula. A negative B. So I have a negative, negative 8. So I have 8 plus or minus my B squared. Well, B squared is 64. Minus 4 times AC. So I have my 4 times A is 4 times C is 7. It actually gives me 112 when I multiply that all together. All over 2A. In this case, my A is 4. So it gives me a pretty big a to deal with now. So I have x equals 8 plus or minus. When we do the work, this is actually negative 48. So negative 48, I already know I'm pulling an I out. I'm going to do this one a little differently because some of you might want to pull the I out right away. Go ahead and do that. Pull the I out so you're dealing with a 48. 48 is 16 times 3. So now I have 8 plus or minus. Well, there's a perfect square, 16. So I pull my 4 out with my I. I'm left with square root of 3. There is no perfect square of 3. And my last step is to factor out a 4. I always factor the top out so I see what I'm left over with one nice fraction with the same denominator. So I pull out my 4. I'm left with 2 plus or minus I square root of 3 all over 8. My 4 cancels out, so I am actually left with x equals 2 plus or minus I square root of 3 all over 2. So that is example 5. When they give us something that's factored, we need to go backward, distribute, combine everything to get your ABC. So again, we've done that a lot. We learned in the beginning how to factor out, and then we've been bouncing back and forth with, do we have to factor or do we have to distribute? So we have to decide what concept we're dealing with to know if we're factoring out or if we're distributing so that we can combine. In this case, we need to distribute and combine. Okay, I want to do one more. Example 6 is pretty intense. 12 minutes, we got plenty of time. This says solve 27t cubed minus 8 equals 0. Okay, so the key here is we're back to, I'll write it like this. We're back to a cubed minus b cubed. So when we have a cubed minus b cubed, remember, this goes back, and you can always look at your formula. This goes back to the perfect cube plus a perfect cube minus a perfect cube. And I just checked my notes to see, and I can't remember, I think it was chapter 2 where we ran into this initially. But I want to say page 26, 28, somewhere in there is where this shows up. And they gave it to us twice at the very beginning, and then they just assume we'll remember. But what we end up with is you have your perfect cube minus a perfect cube. We're dealing with AB because I believe that's what the book uses. And then we want to say what's going to happen is we're going to have an a squared plus AB plus b squared. Remember, the negative has a plus plus. When we're dealing with our positive, we have a minus in there. So what we're doing is saying our a, because we need a, our perfect cube, 27, the cube root of 27 is 3. The cube root of t cubed is t. Our b is the cube root of 8. I know it's negative. However, keep in mind that's what we're dealing with. If we have a negative b cubed, we plug it in here. So we treat the b as a 2. Not a negative 2, but a 2. So I have my a is 3t, my b is 2. Perfect cube, 27 is perfect cube, 3 is the cube root. T cubed, perfect cube, t is the cube root. 8, 2 is the cube root. So I plug this in. I'll do it over here so that we can follow along. So I have 3t minus 2, my a and my b. So here's my a, here's my b, boom. Then I just square my total a, 9t squared. Now I multiply the two together. So my a and my b, it's 3t times 2 is 6t. Then I square my b. which is 4. And I have this piece. So now, basically what I have to do here now is I need to set that whole piece equal to 0. So I need to solve this one separately. I need 3t minus 2 equals 0. So 3t equals 2. Divide by 3, t equals 2/3. There's one answer. So I'm going to have 3 answers to this puppy. One answer is t equals 2/3. Now I go back to my quadratic formula for the second piece of this. I'm just going to make room up here. Now I am looking at 9t squared plus 6t plus 4 equals 0. So my A is 9, my B is 6, my C is 4. So I have a negative B. In this case, it's a positive 6. So my negative B is going to be negative 6 plus or minus B squared. So 36. Then I'm going to take away 4AC, which ends up 144. 4 times 9 is 36. 36 times 4, 144. That's all going to be over 2A is 18. So negative 6 plus or minus, and I'm going to have a negative, so I can pull an I out. Negative 108, I believe, all over 18. Since I have a square root, I know I'm looking for a perfect square to factor. Well, you know what? I'm going to pull the I out right now. I want to get you used to doing that, just to have it set. I'm going to pull the I out. Now, my 108, to start factoring this out, I need to figure out what's going to happen. Let's try, like if we were to take, you can go ahead and do this route if you want, if you don't see something right away. With 2, it's not going to give you a perfect cube. So if we try 3, if we try to factor a 3 out, you see that 36 times 3 gives us our 108. 36 is our perfect cube. You don't have to start with a 36. You can just work your way up the ladder. That's what I like doing with a bigger number. So what we know is we have square root of 36 times 3 all over 18. Now I'm going to squeeze this in. I can pull my 6 out. I have negative 6 plus or minus perfect cube or perfect square of 36. The square root is 6, and I'm left with square root of 3 all over 18. So I can pull a 6 out, and I have negative 1 plus or minus I square root of 3 all over 18. That whittles down, and I'm left with t equals 2/3. T equals negative 1 plus or minus I squared root of 3 all over 3. I think that's the last one that I want to do. Yep. I want you to look at example 7. It's a worded problem, so I'm not going to write it down here because I'm already at 19 minutes. So if you look at example 7, you will see that in some science classes. And it's one of those where you do all the work and you get 2 answers and you know it can't be a negative. I think it's talking acceleration, or it's talking length of time. How long does it take the object to fall? It doesn't take a negative amount of time. So you get 2 possible answers. Only one of them is correct. You have to go with the positive. Okay, so I'm almost out of time. That's the quadratic formula. Find A, B, C, and just plug them in. The key is finding them. This is about as complex as it's going to get if they give you perfect cubes. All right, I had fun. I hope you did.